Okay, and since we have a little bit rolling here, and this is going to be an active participation, I'm going to give you about 10 minutes of kind of just overview of what TDD is, what a coding kata is, and go over TDD a little bit. And then we're gonna participate. You know, everybody. I love it if everybody participated, but I understand if you just want to follow along, but that's fine too. But at any rate, can you do please go to Slack and do DND for 90 minutes, and just let's ignore Slack for a good 90 minutes and concentrate on learning what TDD is. So here we go, test-driven development. And I'm coming at you with this kata, and a kata is typically used with martial arts, and it's a way of developing muscle memory. And if you're old like me, you remember Karate Kid with the wax on, wax off, and he was building up muscle memory to do the blocks and watch out for sweeping the leg and that sort of stuff. So the idea here is that you're building up muscle memory. And so when we're talking about coding, there's lots of katas out there, and this particular one is about TDD, or test-driven development. And the reason why we would do that is to get your mind in a time frame, in a frame of just being in a habit of doing the test first. And it really helps as you're approaching doing your coding to think about, how is someone going to use this code that I'm developing? And the way that someone would use it usually comes out a lot like what your tests look like. And so it helps you really build good habits. And I found it a great way to learn language. I first saw this demo by Robert Martin about 10 years ago, and he did it in Java, and I've done it in Java. I was learning Java at the time. I've done it in C#, I've done it in Python, I've done it in Node.js, and we're going to show it to you here in Go. But it's a great way, once you know it, to translate that into another language, because really the first thing you want to do in any language is kind of learn how to do the testing and stuff anyway. So, and it touches a bunch of sort of basic core ways of programming, arrays, for loops, if statements, those types of things. And any of those things are going to be common parts of a language, and you're going to want to know how to learn it. So I recommend learning this kata and using it. And using it on a daily basis too. If you start using it, you'll quickly find that you can do it fairly quickly. I can do it in about a half an hour or less. And it's a great way to kind of warm up your mind, or even if you're on a project or a certain Scrum story where you're not doing a lot of coding and you're kind of missing it, it's a good way to kind of keep in touch with some coding. And why test-driven development? Well, you kind of threw a troll question at me early on. Well, why do we test it all? And we test it all so that we're comfortable doing changes in code. And changing code is part of coding. I mean, code needs to be designed for change. It's part of Agile, and Agile is designed for change. And so you can see that we have these cycles in Agile. Every quarter, we're doing these backlog planning. Every 2 weeks, we're doing sprints, 2 or 3 weeks. Daily, we do stand-ups and Scrum. We have these cycles all over TDD, or all over Agile, and TDD is part of it, where we have this cycle of test, get a red, develop, test, get a green, refactor, test, get a green again. That's the part that's missing from this one. And it helps you get this sort of idea of maybe not a minimum viable product, but you have working code at the end of each cycle. And so you can stop anywhere where you're at. And if you have working tests, okay, well, I have a skateboard. I haven't made the car yet, but I have a skateboard, and it works. And it works for all the requirements that a skateboard has. It doesn't work for all the requirements that a car has, but it works for everything that I've written a test for, which in this case is a skateboard or maybe a scooter. So the idea here is, again, it's a good place. We all get interrupted when we're coding. If you're always testing, you always know where you left off, because you can just look at the last passing test.
I would like to add, as opposed to 500 lines of code 2 weeks later, how do you figure out exactly what's defined within it, what it is that this code does? You have to read it all over again, as opposed to reading 10 test method signatures.
Right. Yeah. And just to give everybody credit here, I did not write this kata. What I'm going to demo, I mentioned I saw Robert Martin do it at an Agile conference 10 years ago. And I've watched several people do it on YouTube. There's lots and lots of examples of this kata in GitHub. So if you walk away from this, come back to it in a couple of days, I should really test that TDD stuff out. Do a search in GitHub, and you'll find 100 people doing this version of it in whatever language you want. So hopefully they come out somewhat close to this. The kata is based around bowling. You can see I'm running a bowling video here in the background to keep it in theme. And just to quickly cover bowling for everybody, and they may not be aware of some of the nuances of bowling scoring. Bowling is a game where you roll a ball down a lane, try to knock over 10 pins. You have 2 tries to do that in each frame, what they call a frame, and there's 10 frames in the game. So if you knock down all 10 in 2 balls, that's called a spare, and a spare awards you the points from the next roll after you roll the spare. If you knock them all in one roll, the first roll of the frame, you get points for the next 2 rolls as part of what's called a strike. And then the last frame is a little bit of a special frame where if you get that spare or the strike here, there's enough extra rolls in here to cover that first roll of a strike or a spare. You can roll again still. So let's move on there. And if you have any questions about bowling scoring during the workshop, feel free to ask me. These are the requirements. What we're building is a library that can score a game of bowling. So we're going to have a game entity. It's going to have a roll method, which takes a number of pins that were knocked down. And it's going to have a score method, which gives you the score at the end of the game. So if you were going to do this in a typical, let's go get in front of this and design this thing and then go out and code before we do any testing and that sort of stuff, you might say, well, obviously we need a game class, and then like I mentioned, there's frames. So we'll probably need a frame class, and the game might have a collection of 10 frames in it. And then the frames will have a roll method on it. And the 10th frame is a special version of the frame class. And then you have to iterate to get the score. You're going to have to iterate through all the frames and calculate all the scores of each frame to get the final score. And then because you're going to need to know that, like I mentioned, the strike and the spare look against the frame after that, the frame's going to have a reference to the next frame. So this would be a typical way of sort of doing the waterfall method of, okay, we need to design everything out. Okay, now we need to go out and build all these classes. But we're doing a test-driven method. So we're going to drive the design by test. So you'll see that it's not going to end up looking anything like this by the end. And just to cover the coding loop of test-driven development here, we have on the left here, you're focusing on getting the contract is defined by the test, is what it says on the bottom there. So the idea here is you're going to write a test that's going to cover some aspect of what you're coding, in this case, the bowling game. We're going to write the test. We're going to see if it fails. If it's not failing, we're never going to know if it's actually testing code, right? Because if it's succeeding and it's not actually doing anything against the code that we're trying to test, then we don't know if that test actually works. So we want it to fail first. And then we're going to write only enough code to make it succeed. And once it succeeds, we're going to make sure that all the tests succeed. And then we can do some refactoring because we feel safe, because now everything is green and we can refactor. If we have to update tests because of other refactor, we can do that. We can correct any regressions, and then we're going to iterate. We're going to go to the next test. And this is the cycle it's important.
Sometimes called red-green refactor.
Yeah. And the important thing to consider as you're building this stuff is that we still want to follow all the regular principles that we would follow for any good coding conventions. So the solid principles, we need to think about the single responsibility principle. We need to think about how our classes are translating, that they're only doing one thing at a time. All of those coding principles, are going to apply to what you're coding all along the way.
Dependency injection as well.
Yeah.
It fundamentally changes how you start writing your code. You can start writing your code in a non-testable way, which makes it really hard to go back and change that. And if you start with the mindset of testing, then you're better off for it.
Okay, so here are my expectations. We're about to go into the coding bits here. So, excuse me. I'm not going to dive too deep into coding. None of the coding that we're going to see here is very complex coding. We're not dealing with learning how to do Salesforce libraries or anything like that. It's fairly simple coding. We have for loops, arrays. We're going to import the testing library. I might tell you about pointers if someone has a question about that. It's not deep into pointers. It's just that's part of Go. If you have a question about the way I did a keyboard shortcut, feel free to ask. But I'm going to try to limit the rabbit holes. We don't want to dive too deep into coding here. We only have a limited amount of time, and we have a lot to type in here. So,
hey Jeff, good question. Can you hear me?
Yep.
So you would still do that high-level design that you showed earlier, but then as you start writing the code, you would take the TDD approach. Is that a correct understanding?
Not exactly. I mean, you'll see how this works out. That what we end up will not have those same. That thing showed at least 2 different classes and a bunch of different references to different classes that we have. You'll see how this plays out. And the whole point of it is, yeah, you might end up that way, but only if the tests drive you that way. So the idea here is you let the tests drive the development. And again, you still want to follow the good, solid principles. So if it comes time that your class is doing too many things, or your functions are doing too many things, it's time to break out into new functions or new classes to keep the single responsibility principle and the other things that are part of the solid agile principles. And you guys can feel free to Google solid programming principles, and you'll see what all those are.
If I can jump in for one sec, the diagram that Jeff showed earlier of the blocks, I would use that to inform which way my tests are going, but I would not let that constrain me.
That's a good way to approach it too.
Yeah, it's a good mental exercise for sure to have all the pieces and make sure you know what all the pieces are, I suppose.
Yeah. So again, I'm showing you this kata, and the result of this is you have an exercise that you can go to and sort of do the wax on, wax off kata techniques here. Practice this kata as it is, but you approach it every time of we're gonna write 5 tests and the code that makes those tests work, and that's the kata. I'm also going to talk to you about TDD and how it works. The kata itself is focused on TDD. So let's jump into, if you feel comfortable going in VS Code or Goland or whatever, feel free to spin that up. I'm going to use this REPL.IT. If you have not logged into REPL.IT, you can just go to REPL.IT and click on New REPL, and then choose Go. You might have to type it in. Okay, choose Go. I'm gonna close this incognito window and just open it because I've logged in. And it's kind of nice. This little app is kind of nice because it saves all of your previous runs, and you can hook it into your GitLab login or GitHub login. Excuse me. So I'm just gonna create a new Go one. It gives you the kind of the funny naming like Docker does for its things. So Lost Insidious Assignment is the one I'm doing today. We're going to create this REPL. And then If you're running in VS Code or Golang, you probably just start with blank. REPL.IT will start you with a couple of files. And so you can't get rid of like the main.go as much as I'd like to. So we're going to adapt to this situation a little bit. So the first thing I want you to do if you're in REPL.IT is change the package to bowling and do it in the main.go, and then in go.mod, we're going to change the module again to bowling. Okay. And then in REPL.IT also, this is another constraint because we're going to do a lot of testing. And if you add a .REPL.IT file, just that's all it's named, and do run equals quote go test -v, which is the go command for testing verbosely. So it shows you each test. That's the command. And now I can hit Control Enter and it runs that REPL.IT file. So if everybody's with me, you should be able to hit Control Enter and you should be able to run tests. If you're running in Golang, you can hit some sort of button. If you're running in VS Code, I recommend bringing up the terminal and typing in go test v. I'm going to assume everybody's at where we're at, where we have no test files and you're able to run. Okay, now we're going to create a file. We're test first, right? So we're going to create a test file first. So we're going to do bowling_test.go. And I'm going to do package bowling_test. Now in Go, you have the option of making your test file in the same package as the stuff you're testing, the unit under test. I prefer to use the _test, and then you're testing more black box. So you don't care about the internals, you only care about the interface. And the first test we're going to do is going to be sort of the simplest way, try to break down the whole requirements into the simplest thing you can do. I wrote bowing. Where did I write bowing?
The file name.
Oh.
Your test file.
Yeah. All right. So obviously we're going to test, so we need to do an import. And we're going to import testing. And then, like I said, I was about to say here, you try to approach the simplest thing you can do. So the simplest thing you can do in bowling is roll a gutter ball. I mean, that's what everybody does when they're first bowling. They're gonna roll a gutter ball. It's the simplest thing. It's also the simplest thing to score, right? Because it scores 0 points. So we're gonna start with the simplest thing. We're gonna write a function test all gutter ball game scores 0. Because remember what we're trying to build here, I go back to the requirement page, is we're going to test this game. It has a roll and a score. And so it says clearly that the score is called at the very end of the game. It's going to return that score. So this is going to be the first test we do. And then we're going to have a variable parameter called t that is a star testing.t. This is just part of Go. This is the way we do a test. And by having that, we know that it's a test. And I can hit Control Enter again. If you don't have that REPL.IT, you're gonna regret it because you're gonna have to type in this Go test a lot. So we have a working test. Of course, it's not testing anything, but we're kind of in that green state. So, well, now it's time to maybe make our test do something. So let's make a game. Let's instantiate the game by doing G:= game, and then 2 curly braces. And now we should get something like, yeah, there we go, undefined game. So now we're in red again. So let's get out of red. I'm going to go to bowling. I'm going to create a new file, bowling.go. And now we're going to create the actual bowling package. And I'm going to go ahead and create that game. And the way we create a game is type game is a struct. And at this point, it's empty. And now I can run the tests again. And it's still undefined. And the reason I'm undefined is that I haven't imported it. So I'm going to import this with a dot bowling. And you might see me making little mistakes, but the great thing about this technique is it's self-testing, right? I mean, so if I make a mistake, I'll immediately see what the problem is and be able to fix it. So now I'm kind of getting what I expected. The G has been declared but not used. This is kind of a feature of the Go language. You might not see these in other languages where you can just create a variable and not use it. Go cares about these things, and so it's complaining that we haven't used it. So I guess now it's time to make it use it. So we're going to do G. We're going to roll a gutter ball. Okay. And again, now we're using it, but now it's complaining, well, G, the role is not defined. So now we need to go back and create the role. So you can see we're doing the test first, and the test is informing what we're going to build. We haven't even, you know, I could have written out these functions ahead of time, but maybe I don't need it. I mean, obviously I need these ones, but we're going to go here. So we're going to make this a feature of the game struct. So we're going to do G star game. And this is going to be a role. It's going to take in a pins integer, and it's not going to return anything. And now we have a role method. So now I'm green again. I'm going to assume everybody's taking with me. If you need to hold up and ask a question, feel free to interrupt. Okay, so we've rolled one gutter ball, but a game of gutter balls would be 20 gutter balls. So I'm gonna make it roll 20 gutter balls. So I'm gonna use the for loop to do this. I'm gonna say for a roll that starts at index 0, and the roll is less than 20. That's gonna roll 20 gutter balls from 0 to index 19. And I'm going to increment the rolls and format my file there. And so now I'm running rolling 20 gutter balls, still passing. Okay. Well, so this is where we can kind of get into the what a test is in terms of unit testing. So a test, to be a complete test, needs, think of AAA, arrange, act, and assert. So we've arranged the game by building up the game variable and rolling 20 gutter balls. And the roll is also part of the act. And now we need to assert that whatever we're testing actually succeeded. So this is where we're going to need that score. So we're going to do if g.score is not equal to 20. We're going to tell the testing object that we need to send an error. And we're going to, it's nice. This is the other thing I didn't really mention when I did the test. Make the tests super explainable. Everybody should be able to read exactly what this test is testing and what we're expecting out of it. So all gutter ball games score 0. There's really no ambiguity about what that's testing, what it's expecting. So we're going to do something similar here with maybe even a little bit more. So I expected a game of all gutter balls to score 0, but scored, and I'm going to put a placeholder in here for a value instead, and the placeholder is the score.
Jeff, would you say that as we go through this, that the tests ensure that the requirements of the game are enforced, and it sort of acts as a blueprint of what the game is?
Yeah, absolutely. I mean, they're telling you what the requirements are. They're telling you what the code actually does. So remember that MVP picture here. We're about to build a skateboard because now we have a complete test. We've arranged, we've acted, and we're asserting. We're asserting that, oh, I said 20 instead of 0. We're asserting that that exists, but we don't have a score yet. So let's go build a score function. So func g game score. Score doesn't take any arguments, and it returns an integer. And remember the cycle here is that we do I went not far enough. Where is it? There it is. We do only enough code to make the test pass. All right. So I'm going to do two things here. So first, I'm going to return -1 because I want to make sure that my test actually works with that assert and that it's giving me the message I'm expecting. So I'm going to start with a -1. And now I can see that my test is telling me exactly, we expected a game of all gutter balls to score 0, but it scored -1 instead. So that worked exactly pretty much like I expected, that assert did. And now to make the test actually green, we're expecting it to be 0. So if we make it 0, boom, we have a working test for green. Okay, now I can walk away. I have a skateboard. I have a piece of code that can test every gutter ball that it was ever rolled in bowling. So I can come back to it and say, okay, well, games of bowling tend to do a little bit more than that. So let's do a new one. And I think I want to test all, I'm going to roll a single pin each time for 20 rolls or 10 frames. And it turns out my test is going to look very similar, which is a little bit of a code smell, but it also helps me kind of keep the formatting going. So all single pin rolls score 20. And so instead of rolling 0s, I'm going to roll 1s, and I'm going to expect it to roll 20. And you can see I'm just changing a few things as part of this thing, which is a little bit of a smell that says I should not be repeating myself so much. But we'll come back to that because we'll be able to refactor once our tests are passing. So this is a game of all single pin rolls, and we're expecting it to score 20. Okay, and I'm going to run it, and of course it's going to fail because I'm only returning 0 before. So now we actually need to make our code do something a little bit more than returning 0. And so let's keep track of the score at the struct level. It's an integer. And we're going to say g.score plus equals the pins that are coming in from the roll. And then we're going to return the g.score here. Okay. So now I'm green. I have a class that can score, actual pins being rolled down. I can score a game of all single pin rolls. So now we get to this point where, okay, we have these tests and I'm repeating myself. So there's a bit of a smell here. So let's take a couple of these things and refactor it. So here I'm going to refactor. I've highlighted 10 through 12 there. And I'm going to make a new function called roll many. I'm going to take in a game, in this case, a reference to a game or a pointer to a game. I'm going to ask, I'm going to tell it how many pins I want to roll and how many rolls I want. Those are both integers. And I'm going to paste this in. And so now I'm going to replace this 20 with how many, it should have been rolls, how many rolls I wanted. And this with how many pins I wanted to knock down. So we're going to roll many with a bunch of pins here. And now I can replace this and say roll many G pins. We're going to roll 0, 20 of them. And you'll see that the editor, well, we'll get an error here. And this is that pointer issue I was telling you about. So the easiest way to fix this is actually make your game a pointer instead of an actual struct. So we're making our G a reference to the pointer, a pointer of the game instead of the game itself. And so now when I run this, we're back to working. And now I can replace this section here. And now I'm not repeating myself because I'm calling this method. And I just need to change that. So now I'm rolling many, and I'm quickly making my code a lot cleaner because I'm not repeating myself. So I'm going to do the same thing here with the assert. And so I'm going to do function assert score. This time we're going to take the expected, the actual, Those are both ints. I'm going to take the scenario, the string, and I need to reference that testing object. So we're going to do t, which is a testing.t. Paste, and then so now I'm pasting this in. This is going to be the actual against the expected. Okay, and then game of all gutter balls is sort of the scenario we got here. So I'm gonna say I'm gonna leave that as a replacement and put scenario. And then we expected it to score 20, so this is obviously expected. So we'll make this a value as well. And then we have expected. And then it's not G score, but the actual. So the actual here. All right, so now we have assert score. I haven't used it, so testing didn't do anything, but let's go ahead and use it. So assert score, expected 0. The actual is G dot score. And the scenario is all gutter ball game. And oops, and there's the T. Now we'll test. Hey, it worked. So I can use it down here too. Assert score. This time I expect 20. The actual is still the G.score. I don't know why tab is misbehaving, but scenario is single pin roll game. Okay, everybody with me? Okay, so we have two nice clean tests, 3 lines each, no repeated code. They're using functions within it. And now I have a library that I know can score gutterball games and it can score all single pin roll games. So the next most complex thing we got here, we can score a frame that scores under 10. We know that because we have, we're scoring frames of 1 roll each, that, and we get that. So let's do spares now. So next one is a spare scores 10 plus next roll. And T testing, T. Okay, we're going to arrange the game in the same way. Okay, but now we need to roll a spare. So a spare, as you guys all learned, is when you knock down the 10 pins with 2 rolls. So let's do that. Let's roll a 9, and then we'll roll a 1, and this is a spare. And so this right away is kind of a smell too, that I have to point out that that's a spare, but we'll get back to that. And then we have the next roll, right? So I could just use a 1, but I like to use something a little bit unique. So if I'm debugging, you're not using the same number over and over again. You can kind of use a number that is easy to pick up. So I'm going to just use 3. Feel free to use whatever you want, but obviously use less than 10 because there's only 10 pins. Okay. And now, so before we were rolling 20, and now we've rolled a spare, which didn't eat up anything the way a strike does, but we only have 17 rolls left in the game. So let's go ahead and roll.
We lost your
Jeff,
audio.
your audio died.
Jeff, your audio died. Oh, I don't think he can hear us.
We can't hear you, Jeff.
Can you hear me, Suhas?
Yeah,
Yes, I
we can hear you.
It's funny. Everybody can hear each other except Jeff to us and us to Jeff.
Right.
He's on Bluetooth. I want his Bluetooth headphones died.
Oh,
Yep.
I blame wireless headphones.
Yeah.
I think so.
Yep.
I've seen it happen before.
Understood. I don't know how I was able to say Bluetooth with my hands, but apparently I was able to.
Can you hear me?
Yes.
All right, I'm going to try to switch back to my gaming headset here.
Hey, Jeff.
Can you still hear me?
Yes.
Okay.
Do you mind opening your main.go for a sec?
Yeah. Where did I drop out?
You were right at maybe about 10 seconds. You spoke about 10 seconds.
Right after after you made roll many, line 27, that beginning of that.
Okay.
I started to type roll.
Okay, I will jump back to help you out with the main here in a second, Yusuf.
No problem.
But let me finish out what I was talking about. So the
Yep.
roll many 17, we still have 10 frames, 2 rolls each. We needed to roll 20. We were rolling 20 up here. We've rolled 3 so far, so we have 17 left. Just want to make sure that that's clear. And then I was saying, the other thing I wanted to say is that here, I don't like to add up these numbers on myself. I mean, I can, it's 33, but an easy way to kind of explain exactly to the next, remember, you're writing tests for the next person, not necessarily for yourself, or it's yourself, but a month from now where you don't remember how a game of bowling is scored. So, so I'm going to say, well, we want that frame, the spare to score 13. And then the next frame is going to score that 3 that we rolled. And then well, not the next frame, but the next roll. And then there's 17 ones after it. So that almost makes it a little bit more clear of exactly what you're testing. And because the compiler is going to add all that up before it sends it into the assert, you don't have to think about it too much, but you've really explained what you're trying to do here. So, and then we do the score. And
What you mentioned there is a matter of code readability, so that the number, so that the expected number makes sense from a gaming standpoint.
Yeah, and it's exactly what what the function actually says too. So it scores 10 plus the next roll. So there's the 10 and the next roll, and then the next roll actually gets the score still. I mean, otherwise that wouldn't be much of a bonus. And so we can say this. So spare followed by 3 and 17 ones. Okay, and we expect that to score whatever this adds up to be, which we know is 33. So I'm going to format that with a Control-Shift-F. I'm sorry, Shift-Alt-F does a format. And I'm going to go ahead and run this. And then I'll show you, I'll go back to the bowling here so you can take a look at that. So, oh, why didn't it run? I saw it reload. I wonder if that has something to do with the reload. I'm just going to hit reload on the whole thing and see if that fixes it. It should be failing, but I only see 2 tests there, so it's almost like it's not there yet.
Jeff, doesn't the function need to start with test to be discovered?
Oh, there you go. Thank you.
Great.
There we go. Thank you. All right. So now we have the error that we were expecting. We were expecting to score 33, but it scored 30 instead. Okay, and now I will go back to bowling. So now I'm looking at this code and I'm like, well, spares really kind of require some concept of a frame to do some stuff. So I'm tempted to sort of figure out how to do frames here. But the other thing I'm noticing is that the roll is not really tracking the rolls. It's really adding to the score. And score is just being a kind of a dumb return operator. So I want to change this around. So before I'm going to do this refactor, I want to go back and make sure that everything's green, and I want to keep everything green during my refactor. So I'm going to comment this out. And I did that with a Control/. I highlighted in Control/. And so now I can run the tests and I'm all green. And so now I feel super comfortable. I'm able to refactor. So I'm going to refactor this. Instead of keeping track of a score as an integer, I'm going to keep track of score as an array of integers. So that's going to be the roles, which is an array, a slice of integers in Golang. And instead of adding to a score, I'm going to append to my slice. So I'm going to say g.roles equals append. You can tell what you're going to append to g.roles and what you're going to append to it. That's still failing, of course. G.score is undefined. Oh, because I call it roles. Oh, yeah, G.score is undefined, right? So now we need to actually make score do something. So let's start up score equals 0. We're going to calculate the score. So now we're going to loop through those roles. So for roll 0 roll is less than the length of the roles slice roll plus plus. And now we can say score plus equals roles. Use the bracket now. Roll to address that bracket. And now we can return score. Okay, so now I have changed every line in those two functions 100% completely, but I'm green, and I was super comfortable doing it because I knew exactly what it was supposed to do, and I did it. So this is a really powerful thing to recognize here, is that I just changed the entire contents of two functions, and I still passed all the tests that were passing before I started. So I know that I've refactored successfully. Any questions on that point?
That assumes that you're comfortable with the extent of your testing, right?
Well, yeah. I mean, obviously this is not a complete test yet. We're still at maybe the skateboard stage or whatever. But you know, we have a game that can score gutter balls, and it can score someone rolling not spares or strikes. So I'm comfortable with where it's at. It's not an MVP by any means, but it does what it says it does.
Yeah, you know that you didn't break any of the test cases that you know already worked.
Yeah.
Yeah.
Well,
that's where the comfort level comes in.
So now my role is actually keeping track of roles, and my score is actually calculating the score now. So that's a little bit more in line with what those methods maybe should be doing, but I still don't have the concept of frames yet. So let's refactor one more time here. So maybe instead of looping through the roles, we really should be looping through the frames. So I'm going to change this to frame. Frame is less than, there's only 10 frames in a game, and we're going to loop through the frames. And I'm going to instantiate the role here. Now I'm still failing because I need to, score needs to add 2 roles. So let's do that. Plus, and the role after it. And because I'm kind of looping through the score or the roles twice as fast, let's do plus equals 2. Okay. So now I have a concept of frames. I've refactored again, and everything's still working. And now I feel like I'm ready to sort of address this spare problem. Okay, so let's go back to the spare. And so we're going to test again. We're going to start with our red. Okay, so we're back to where we were. Refactored both of those functions completely. But now I feel like, okay, well, if the role and the role after it is 10, well, that's a spare. So I can say if that equals 10, then that's a spare. And you'll notice I have a comment again there, just like I did in the test, which is kind of a smell. Otherwise, the score is going to be that. And so now let's score, just like the test says, let's just score of a spare is 10 plus plus the next roll. So that's going to be roll plus 2. So g dot rolls roll plus 2. Okay. I don't know why it's not formatting now, but let's format myself here. Okay, and now all 3 tests are passing. Okay. But it's refactor time because we have these smells we need to take care of. So let's take this code right here where we detect if it's a spare, and we'll make an internal function still on the game is spare. It's going to take in the roll as an integer, and it's going to return a Boolean. And I copied that, so I just pasted that in. So now I'm returning whether or not roll and roll plus 1 equals 10. That tells me if it's a spare or not. So now I can go ahead and use that. And now there's no question of what I'm doing here because I'm calling a method called isSpare, and it's going to tell me whether it's a spare or not. So you don't have this kind of obtuse measurement of 10 and the rolls or whatever. We're defining what that is, and that makes it really easy for the next person, even yourself, to come along and know what is going on here. And so we should test that because we just refactored. Still works. And similarly, we have the score here. So maybe I should do g dot score spare frame. Need to take the roll function. G lost all my IntelliSense when I reloaded there. We're going to take in the roll as an int, and this one's going to return an int. And so it's going to return exactly what the test says is the spare is, right? The test says a spare scores 10 plus the next roll, and a spare is 2 rolls, so the next roll after that is plus 2. And so it's really fulfilling the test. So let's make sure that we didn't break anything. I'm going to reload one more time and see if it gives me my IntelliSense back. Maybe it will. Okay, and let's do the same thing here. So we're scoring a spare frame. I guess we should probably score a normal frame. So G score normal frame. Score normal frame. It returns an int as well. Okay, and here's a little go tip. If your IDE stops working, as this has, and often VS Code does too, you can say go FMT and it will format things for you. Okay, so I'm all squared away there. Let's test one more time just to make sure everything's cool. Okay, so now this seems pretty clear. I know exactly what the score is doing. It's looping through the frames, 10 of them. It's checking to see if it's a spare. If it's a spare, it's going to score it like a spare. Otherwise, it's going to score it like a normal frame. Seems simple enough. The function's super simple. Let's go back to the test. We had a couple of smells here, or a smell. So here I'm going to say I want this to be roll spare. And we need to pass in the game. So let's just put that right next to our roll many. So func roll spare game. And so now it's super clear to the next person that comes along. We're rolling a spare, then we're rolling another roll. And now it's doing pretty much what the scenario says. It's rolling a spare, followed by a 3, followed by 17 ones. So arrange, act, assert. All right. So again, I just want to stress this is sort of the transformative test here. I promised you 5 tests. We're up to 3. And this was the one where we do this big transform. We do this big refactor where I've refactored the way the role works. I've refactored the way the score works. I've added a bunch of internal functions. Notice I'm not testing those internal functions individually because I'm doing this outside test here. I don't care how the class works internally. The unit under test in this case is the class and the game class, or the game struct in the case of Go here. So let's continue on. So the next thing we need to do is score those strikes. So test strike scores 10 plus next 2 rolls. And it's that testing.t. And so let's set it up in here. Okay, so let's roll a strike. G.roll 10. That's a strike. And we need to do something similar to what we did with the roll 3 above there. So I'm just going to grab that real quick so I don't have to retype it. Let's do a 3, and then since it's 2 rolls, and again, I like to keep those numbers separate so that I know, if I have to debug it. I mean, this is obviously a simple case here, but think about when you're sending in these values during your tests. If you have to debug this later, I know that, okay, I'm on the one where I rolled a 3 because I can look at the value in the debugging or whatever and see that I rolled a 3 or I rolled a 4 this time. So, and then we need to finish out the game. So now because a strike advances the frame, there's only 16 left here. So that's something that I'm sure will show itself here. So if we're expecting this to be 17 for the strike, so 10 plus the 3 plus the 4, it's the 10 plus the next 2 rolls, plus the 7 itself, the 7 frame itself, plus the 16 ones. So, and I'm going to do something similar here where I say strike followed by 7 frame followed by 16 ones. Okay, any question on that test? And now when I run, I get a big panic, which is Go's way of saying that there's been an exception of some sort. And you can see in here that the index is out of range. So I've told it to roll the ball 19 times, right? But it's trying to check. It's trying to check that roll plus 1 here, so it didn't get up to the 20, even though it's rolled 10 times. So let's go fix that. So I've tested for a spare here. I guess we need to test for a strike. So if g.rolls roll equals 10. Else before I forget, and that's a strike. Then the score plus equals 10 plus the next 2 rolls, right? So I'm just going to come down here, save myself some typing, and lose my place. 10 plus that, so we need the next 2 rolls. So that the roll is the current roll. So the next 2 is plus 1 plus 2. Okay, but then I haven't addressed the fact that only one ball has gone by here. So this roll plus 2 needs to kind of move up into here. And I can say roll plus 1 here. Okay, and now I'm passing again. And I'm going to format my file. Everybody with me so far? Okay, So we're going to do a similar refactor here. So we got an is spare. We might as well have an is strike. So G dot is strike, maybe someday. We're going to pass in the role. Is strike, takes a roll, integer, returns Boolean. Okay, and we don't need that comment anymore because the function is very clear about what it's doing. Okay, still passing. We refactored with no passing, and with similar. Okay, and similar to the spare frame here, we're going to do the same thing here. So let's Control X that out. G dot score strike frame roll. We'll put it next to the other ones. Score strike frame roll. Turns an integer. Okay, test again.
It's been great fun watching you code, Jeff. Is anybody even trying to keep up with you? I can't.
I am 100% kept up, but I don't know what's wrong with my main.go.
That's awesome.
You want to tell me your error? I could probably tell you what the problem is. Oh, the main.go. Did you change? If you're getting a problem in main.go, the only change you should have done to that is change it to package bowling.
Let's see your code.
I was failing until I had the go.mod updated to say module bowling as well.
And yeah, and then the go, this is, yeah, and the module needs to say bowling as well. Okay, but now I promised you 5 tests. The last test, well, if we can throw a strike now, what happens if we can roll around a perfect game? So that, well, I actually I should refactor this first. So let's roll a strike. Roll strike game. Roll strike. Okay, so now, again, our test is super clear. Rolls strike scores 10 plus the next 2 rolls, or the strike plus the next two true rolls. Our scenario says that same thing. So now let's do func test perfect game scores. How much is a perfect game score? Keep you guys interactive here.
300.
Thank you.
300.
T testing.
I can't keep up with the coding, but I'll answer the bowling question.
Okay, so now we need to roll. And how many strikes do you roll to get 300? Do you know?
12?
11.
12, I think, right?
12, right? You get 2 bonus frame or 2
12?
bonus rolls.
Yeah, that's right.
Yeah.
You get the 2 bonus.
9,
So,
12, yes.
so roll many. There's my IntelliSense. Pass in the game. We're gonna roll strikes. We're gonna roll 12 of them. And I'm gonna copy this assert here. So we're expecting it to roll 300. And just because perfect game of 12 strikes. Okay, that way, in case there's any question about how many strikes there are, we're being explicit. And I don't have all my IntelliSense, so let's go FMT. Any bets as to whether this passes or not? It should pass because we haven't really added any more functionality. So there's that. So we passed. Now, there are a couple of things that I might, in a code review or a merge request, point out to people. We have these things here called what I would call magic numbers. I mean, it's not super clear why there's 10 here, unless I happen to know that there's 10 frames in a game. Why I'm only going 1 roll here, but 2 rolls here. So I could do some constants here to help explain that. So I could say const frames in game equals 10, and replace that. And then I could say rolls in strike frame equals 1, and rolls in normal frame equals 2. Copy that.
Could you take that at the game class level, the whole const?
Yeah, well, I tend to like to use stuff closer to where I tend to like to define stuff closer to where I use it. If I was going to use it throughout the class, I could certainly put this higher. But really, only the scorer is using it at this point.
Hey, Jeff, how would you account for the last frame where there would be 3 strike rolls?
Well, I mean, so this is not a complete library. You would want to continue on, but this is at the end of the kata. So if you wanted to continue on, you might do, well, maybe a frame should only ever add up to 10. I mean, it can't add up to more than 10. So maybe you would want to put a validation that 2 rolls are not adding up to more than 10. And then maybe you want to do something like that where you make sure that there's no more than 2 rolls per frame and potentially 3 rolls in the 10th frame. You know, so you could put some validations on that here. So like I said, this is the end of the kata, but there's lots more that you could do if you were actually building out the library. But the kata is these 5 tests. And if you know those 5 tests, whatever language you go to, you should be able to figure out the rest. You know, when I jump back to like a Python or Node, I'm programming in so many languages. I don't remember all the nuances of appending a value into an array or whatever. So I just Google it. But do that code several times in a row. Several days in a row. Just start out your day and do it. It's sort of like a warm-up exercise, and you'll get that. You'll kind of get that. Your brain's all warmed up and ready to write tests and then write production code. So that's the end of the kata. Does that answer your question? I hope it does. Are there any other questions that I can answer about this kata, about TDD? I think I'm a little over time already. Or no, I have another half hour. That's why I did that extra half hour, so we could talk about anything you wanted to talk about.
No, this was fantastic, Jeff. Loved watching you code like that. And the only I think from my point of view feels like it works because you actually were also refactoring the smells out immediately. I have run into many code reviews in the past where people get happy that their tests are passing and then never refactor the code.
Yeah,
so
that's definitely part of the cycle is write the test, check it, write enough code to make it pass, but then you need to go into refactoring, and that's where those solid principles come into play, and taking care of the magic numbers. I got Satya's approval on the magic numbers, I think. So there's lots of things that could be done. The other, I realized that one thing I could do, because Go allows multiple exit points, is that I could determine because I'm scoring a strike frame, I could set the roll coming out of the strike frame as well. So I could put that rolls and strike frame as a return value here and return 2 integers. So you could really kind of get that code smarter and smarter. But the great thing is you have the tests, so you can refactor all you want. You feel super comfortable doing that. So I'd love to answer any other questions at this point, but otherwise we can let you go.
Hey, Jeff, this is Carol.
Hi, Carol.
I was wondering if this TDD is good for all kind of software development, or if there is a specific thing it's good.
Yeah, I think it's good for all software development. In fact, one of the things I wanted to show here was that I've done lambdas this way. So I'm going to bring up one now if my computer will go with me. But a lot of times in lambdas, you're going to have to do some design called dependency injection, where you're allowing your code to receive mock things that you can kind of control what these external dependencies might return. So your Lambda might go call out to a Dynamo database or something like that. So you would make it so that you can pass in the code that will actually call the Dynamo, but also a code that you can control called a mock or a fake, and force it to do that. Oh, one other thing I want to show
Or
you.
a patch.
Yeah, one other thing I want to show before I left this code and showed you the one I've done with the Lambda is any bets to what my coverage is on this?
I know, but I feel like I'm cheating.
More over 90%.
It is over 90. And the only reason it's less than 100 is because of the stuff that the REPL.IT left for me. So if I just take that all out, I actually have 100% coverage at this point. Now, you don't actually, 100's a goal. So, and Go especially has this sort of behavior where you're kind of, especially for external libraries, you need to test these errors on each one. And yeah, it'd be nice to have a test that encompasses what does your code do when this code error, when this library errors, returns an error that, you need to, those are probably the major culprit in what's bringing down coverage. And if it's more expected, or not, then maybe you should test it. If it's less expected, then maybe you keep going. Let me bring